All right, so today I just want to introduce kinematic equations in 2D. We're not going to do a lot with them just on their own, because a lot of what we're going to do involves projectile motion, which is our next topic. So with the kinematic equations in 2D, the best way to work with these is actually AP Physics 1 formula sheet. If you work with the kinematic equations in any other form, like might be in your textbook or Khan Academy, it's sometimes harder to work to kind of go between X and Y with those. But when you use the ones on the formula sheet, they have these extra subscripts, which seemed really annoying when we were working in 1D motion, but are really super helpful in 2D motion. So the three equations that are on the formula sheet are these ones, in the order in which they appear. So those are your three X equations. Remember, just a reminder, as always, there's a fourth equation. Delta X is 1/2 Vx0 plus Vx times delta T. That just tells you displacement is average velocity times time. But since that one's not on there, a lot of people don't remember it, so it's not as used as some of the other ones, although it's a very powerful equation. Now, what's really cool about the way these are written is see all of the subscripts, and everywhere you see an X, if I want these equations in Y, I just have to replace the X with Y's. So I get Vy is equal to Vy0 plus Ayt. I get Y equals Y0 plus Vy0t plus 1/2 Ayt squared. I get Vy squared equals Vy0 squared plus 2Ay y minus y0, and if you wanted to do the last one, delta y is equal to 1/2 Vy0 plus Vy delta t. Now, we now have 8 equations. We went from 4 to 8 equations. We have approximately 12 variables to handle. That is a lot to work with, and it can get a little crazy and overwhelming at times. Fortunately, when we're working problems, you won't need all of the equations, and a lot of times things will be zero, like your initial position might be zero, your initial velocity. So that way you can simplify the equations down. The one thing I want you to note is that the only variable that didn't change in the 2 equations is time. Time doesn't have a subscript. And that's because if I'm moving in 2 dimensions and I have both an X component and a Y component, that I'm going to go through from point A to point B in the same amount of time. This horizontal velocity and the vertical velocity occur at the exact same time. So they'll have some acceleration and some position associated with that. So the time itself is what will link these together. So if I have information about the X area, and I can find time, I can substitute that time over here and find information about the Y. And that's going to be the kind of trick, is to list your variables out, really think about what's going on, check your equations, and find your path. Because if you just try and guess randomly, you don't get into a pattern and a feel for how it works, it will be very overwhelming. So here is a strategy that I suggest. I suggest when you're working in 2 dimensions to set up a clear variable list and use the same variable list anytime that you're working one of these problems. And that'll be different for all of you depending on how you want to work. What I might do would be like x0, x, vx0, vx, ax, t, and then y0, y, vy0, vy, ay, and then theta will also be an angle that kind of relates those together. So those are kind of universal. You might also have like a v0 if you have 2-dimensional initial velocity. You might have a v0. You might also have a v, where these would be the net vectors based on the X and Y components. You could also have a net acceleration. But something along these lines that may change and grow kind of as you develop. And you may not need every variable every time, but especially when you're getting started, just listing out what you know will help you narrow down and choose equations. when we are, when you're working with the equations themselves, you're gonna be solving systems of equations. So when I create a list of what I know, sometimes I might have more information in the y dimension, and I'll start with a y equation and then find information like time or theta from the y equation, in which I can go then and substitute in for the x equations. So without kind of overwhelming you, I just want to kind of give you that kind of general understanding of how the kinematic equations are set up, and kind of a good kind of way to kind of set up as you go to start analyzing problems. Like I said, when we start working in projectile motion, a lot of things will become simpler, because like in projectile motion, there's no horizontal acceleration, because gravity is what causes our acceleration, and it works in the vertical, and our acceleration is negative g. Half the time, our initial position is going to be 0. You might hit the ground at some point, and that's 0. If you have no horizontal acceleration, Vx0 and Vx are the same thing. So there are ways to simplify all of this down, given the certain circumstances. So don't let the total number of variables overwhelm you. All right, we'll work on solving problems later this week. Have a good day.